Hello everyone, we are going to see today astronomical telescope. This astronomical telescope is refracting type. We are knowing that telescope is instrument meant or it is also called device to see heavenly body such as planet, stars, planets, satellite like moon, etc. It is a large cylinder containing two achromatic combination of concave lens, convex lens, achromatic combination L1 and L2. L1 is called objective lens. This objective lens has two property: high focal length. F stand for focus, means we may say low power. The second lens achromatic combination in the tube on second side is known as this is also a convex lens, and it known as eye lens. This eye lens has also property same like as low focal length, means high optical power. It is just opposite to the microscope. The distance between the objective lens and eye lens can be changed in the tube to see the object. To see magnified clear image of the much far object, we use this telescope. How it works? See very carefully with the diagram. Here in this diagram, consider two lenses L1 and L2 ends at the end of the tube of telescope. L1, L2. L1 is called objective lens, where L2 is called eye lens. We have already told this is right. Here in the telescope, the large object heavenly body like star, planet, it is much away from it, so it is considered as at infinity. See the ray diagram. If object is at infinite, parallel beam of light is considered. Right? And this parallel beam of light is focused at the focal point of objective lens. So we are knowing this ray of light which is passes from the optical center undeviated, and if we compare with this diagram, let AB is object it's a small image A dash B dash is formed at focal point of objective lens FO. So FO and A dash is the same point. This is a B dash. Image is formed. Now the image formed by objective lens of distant object behaves as an object for virtual object for eye lens. So this diagram is based on here. See carefully. We will take this final image when it is formed at least distance of distinct vision. It is under this case. Final image is formed at least distance of distinct vision, capital D. So see here in the diagram, to make this, when this ray of light after meeting fall on lens, eye lens, here this, now when it is fall on the eye lens, refracted. This is the first ray, refracted in this direction. Second ray passes through the optical center, reflected in this direction. Now see, this position of the lens I2 is made in such a way that the virtual image formed by A dash B dash is formed at least distance of distinct vision, capital D, from the lens D. If it is formed a higher image, see, proceed backward side. And join this also. So one who view from here, actually the path of ray of light is like this, but one view through the eye lens, it seems to come from here. So final virtual image A double dash B double dash is formed least distance of distinct vision. Now see, carefully see some of the distances here. In this lens, the distance from lens to A dash B dash is at a focal point of this objective lens. So FO is this distance called. VO is equal to FO. Right? This distance is UE for eye lens and capital D is this. Now we will see the formula for magnification, how much time this image is formed. Then A dash B dash, how large it is formed. Magnification in comparison to the first lens. So see carefully. Magnification power is defined as angle subtended by final image at eye. Angle subtended by final image at eye. Final image is this. At eye lens, this angle subtended, let it is beta angle. So this angle will also be beta because it is a vertically opposite angle divided by, now see, in second part it is angle formed. These angles are visible angle. This visible angle from object on I when it is placed at actual position. The actual position of the object is at infinity, and when it is normally viewed, it means, see very carefully in the diagram of a telescope, it is a little different from the microscope. Object is at infinity. See the position of objective lens if it is not here. If only it is through with the eye, human eye, not using by the telescope, it make normally angle, here visible angle, this visible angle is called alpha. Vertically opposite angle, this also can be considered as alpha. So see in the formula, this is angle alpha, upper is angle beta. So magnification M can be considered as beta angle beta by angle alpha. Let it is represented by equation number 1. Now see in the diagram how we will obtain value of beta and alpha, and we will put in this. Now see in the diagram very carefully. To obtain it, what is it is objective lens, so this optical center I am representing by O, this is eye lens E. For determination of beta, visible angle beta, see we are going to take a triangle that is A dash B dash E. Here tan beta is equal to perpendicular, it is A dash B dash by base A dash E. Represent it equation number 2. For determination of alpha, this is visible angle alpha, this angle also alpha. We are taking a triangle here. Again triangle C, A dash B dash O, right angle triangle. Tan alpha is equal to perpendicular, same, A dash B dash by it is C O A dash. Treat this is equation number 2. Now what we are going to do, angle of beta and alpha we are going to keep in equation number 1 is here. See, in that condition, magnification produced by the lens is equal to beta. Beta is A dash B dash by A dash E divided by A dash B dash by O A dash. See here, A dash B dash is cancelled by A dash B dash, so it can be written as M is equal to O A dash will go up A dash E. This is magnification. Now see very carefully, this magnification produced M is O dash A. O dash A, see in the diagram. O A dash, not O A dash. See, it is clear. It is equal to VO FO. So we may write here OA dash is a focal length of objective lens, and it is equal to plus FO, focal length of, because OA dash is equal to plus FO. Now A dash E. A dash E. A dash B dash is works at the object for eye lens. So it is UE and it is on left side, so it is a minus UE. A dash E is minus UE. So finally, M can be written as minus sign of FO by UE. it can be represented as equation number 4. The next plan is we will obtain the value of 1 by UE and will put in the equation number 4. For that we will use Lenz's formula for I lens. Lenz's formula is 1 upon F is equal to 1 upon V minus 1 upon U. F is equal to Fv positive sign. Final image V is formed at least distance of distinct vision, virtual image same side, and U is minus UE. So putting this value here in the formula, one may obtain 1 upon Fv is equal to minus 1 upon D and minus minus plus 1 upon UE. This implies that 1 upon UE is equal to, transfer this side, 1 upon Fv plus 1 upon D. And it can be written as equation number 5. Now what is the plan? We will keep the value of 1 upon UE in equation number 4. When we will keep this value in equation number 4, see the formula for magnification. M is equal to minus FO 1 upon Fv plus 1 upon D. It is Fv we are taking common here, minus FO by Fv 1 plus Fv by D. It is formula to calculate the magnification produced by telescope when final image is formed at least distance of distinct vision. It is Fe. Fe we are taking common. We will see when final image is formed at infinity in the telescope second case. So first of all, see the ray diagram. So in this ray diagram, principal axis inside the tube containing two lenses, objective lens L1 and eye lens L2 here in the diagram. See the, since object is at infinite, object AB, so we will take parallel ray of light from infinite. First ray, second ray. It is passing from the optical center of objective lens undeviated, and it's will meet at a focal point. So large object AB, their image will be formed here, A dash B dash at FO distance from the objective lens. It means it will formed at the focus. This A dash point has also named F, focal length of objective lens. A dash or FO is the same point. Now, the image found by objective lens is a object for eye lens. So see the further ray diagram. This first ray will move forward and fall on the eye lens, and the second lens, which is passes undeviated from optical center, will be strike here on it. This second ray, first ray. After refraction, they will be refracted in the direction. When they refracted in a direction, in which way? See the condition. What is the condition? The position of eye lens is kept in such a way that A dash FO and focal point of eye lens also coincide, all three at a common point. So this distance is called UV is equal to FV here. In that condition, this both refracted ray becomes parallel to each other. When they becomes parallel to each other, when we proceed it, they will neither meet in this side parallel rate nor backward. So all becomes parallel. So this image will be formed at infinity. No will meet anywhere. So final image is at infinity. It is possible only when FO and FP and A dash coincide at a common point. In that condition, think very carefully, see very carefully. Length of tube. See length of the tube. This is FO and this is FP. So we may write FO plus FP from here. Very careful. See the magnification formula for this. Since magnification formula in the question number 4 is magnification is minus FO by UV, but U is equal to FE. Since U is equal to FE, then it can be written as magnification is equal to FO by FE. This is equation number 17. To obtain the magnifying power of refracting type astronomical telescope when it is kept, when final image is formed at infinity, and we have a formula here when final image is formed at a least distance of distinct region. So this is whole about the astronomical refracting type telescope. Thank you and have a nice day.